Good evening, everyone. Now I am going to discuss the histology of a bone. First of all, bone is a mineralized connective tissue that forms the structural framework of vertebral skeleton. Types: microscopically, the bone is of two types, that is, lamellar and oven bone. Lamellar bone is further divided into cortical and cancellous bone based on the arrangement of lamellae. Oven bone is of two types, immature and pathologic bone. In this picture, we are going to see the cortical and cancellous bone. In cortical bone, the lamellae are arranged concentrically, whereas in cancellous bone, they are arranged haphazardly. In this picture, we are showing the immature bone and pathologic bone in cases of giant cell tumor or other tumorous conditions. Now, we shall discuss in detail about the cortical bone. It is also known as the compact bone. It constitutes 80% of the skeleton. It consists of tightly packed osteons. Osteon. What is an osteon? Osteon is the functional unit of a compact bone. It is also known as the Haversian system. The Haversian canals are connected by the Volkmann's canals. The Haversian canals run longitudinally parallel to the long axis of a bone. These are located at the center of osteon. They have arterioles, venules, capillaries, nerves, and lymphatic channels. The Volkmann's canals are the perforating canals. These run obliquely or transversely connecting the Haversian canals. The Volkmann canals also connect the central canal or Haversian canal to the periphery up to the periosteum and medullary cavity centrally. Cement lines are the outer border of osteons. This is the image showing the compact bone and spongy bone. This is the compact bone and this is the spongy or trabecular bone, and this is the osteon or functional unit of a bone. In osteon, there is a central Haversian canal with its vasculature, and these are the Haversian canals. They are run longitudinally parallel to the long axis of a bone, and these are the Volkmann's canals. The Volkmann's canals connect the two Haversian canals, or it also connects the Haversian canal to the periphery, and it also connects the Haversian canal to the center or medullary cavity, and this is the periosteum of a bone. Here the vascularity of the periosteum is seen. Next, interstitial lamellae are between the osteons. The fibrils connect the lamellae but do not cross the cement lines. Nutrition is provided by the intraosseous circulation through canals and canaliculi. Canaliculi are the cell process of the osteons. And now we shall see in this cortical bone detail. This is the osteon. It is the functional unit of a bone. And this is the Haversian canal with its central vasculature. These are the osteocytes, and these are the canaliculi projecting from the osteocytes, but these do not cross the cement line. What is the cement line? Cement line is the outer lining of the osteon. Next, cortical bone. Cortical bone is characterized by slow bone turnover, higher Young's modulus, and it has more stiffness. Cancellous bone. It is a spongy bone, or it is also known as the trabecular bone. Cancellous bone is characterized by high bone turnover, smaller Young's modulus, and it has more elasticity. Now we shall discuss in detail about the properties of these bones of cortical and cancellous. Bone turnover. Bone turnover is also known as the bone remodeling. It is a continuous process by which the old bone is removed and new bone is formed. Bone turnover, bone resorption, bone formation. Bone turnover is based on these two properties, either resorption or formation, and its balance. Resorption is done by osteoclast. Formation is formed by osteoblast. First, we shall see the resorption. These cells, that is, the osteoclasts, break down the old or damaged bone and lead to release of calcium and other minerals into the bloodstream. And in bone formation, the cells build new bone by laying down collagen matrix and mineralizing it with calcium and phosphate. Hence, bone is a mineralized connective tissue. If the resorption is more than formation, it leads to osteoporosis. If the formation is more than resorption, it leads to bone growth and bone healing. Low overall bone turnover occurs with aging or medications like bisphosphonates. In bisphosphonates, overusage or overdose of bisphosphonates leads to atypical femoral neck fractures. Young's modulus. It measures the resistance of a bone material, to elastic deformation. Higher the Young's modulus, higher is the stiffness. Lower the Young's modulus, higher is the elasticity. Lamellar bone. Lamellar bone is of cortical and cancellous types. In cortical bone, the structure is oriented along the lines of stress. Example, femoral shaft. The uh, cancellous bone more elastic than cortical bone. Example, distal femoral metaphysis. Oven bone, immature bone. It is not stress oriented. Example, embryonic skeleton, fracture callus. Pathologic bone, random organization, weak and flexible. Example, in tumorous conditions like osteogenic sarcoma and other conditions like fibrous dysplasia. Thank you.